Okay.
And I've seen to where people are powerful, to where it's like I've asked it.
Hey Matt, are you on the live stream still?
Yeah.
Okay, tell me once you see me on it.
So I've seen
Hey, check now. I think I just figured it out.
We're only limited to.
Do you? Okay, all right. Bye.
So we don't have access, but then they type in.
We got it.
Is Nick gonna join the live stream?
I'm not. Nick, no, he's in a meeting right now.
Oh, I thought he's on a family holiday.
I'm gonna go pick up like 2 more chairs.
He's on a call right now. Are you sure?
Yeah, I think because I saw 3 more people coming up.
Okay, bet.
Are you gonna get some water bottle? Are you gonna get some water bottles?
Matt, tell Rob to bring up the water bottles.
Yeah, thank you.
I will go down as well before we start to make sure. I'm just making sure there's a sound.
Not what Google has. Google has terabytes and terabytes.
Right. So yeah, I think OpenGPT is.
You got done with your school?
Oh, no.
What?
You got done?
Yeah. I finished on Sunday.
You got family or?
No, in LA. Yeah, from Los Angeles. Yeah. All right, the stream works. We got it. Let's go. All right, let me get you water and start setting people up. Thank you. Yes, sir.
I think Peter Thiel, I kind of think, it sounds to me like what they call the PayPal mafia. Did you ever hear that term?
No, I just know he's a part, he created.
You should YouTube that someday. Fascinating. I'm telling you, look at that. That's why I think it's, I think it's the PayPal mafia that's the Toshi Nakamoto. I've always thought that. Not always. I'm not the only one that thinks that. Some people have done handwriting comparisons, or not handwriting, but writing comparisons like phrases and stuff. And for the Satoshi blog post, it goes back to that, which includes Elon Musk. He was one of the programmers.
Right.
So Peter Thiel, it's interesting, whatever. So you get into that, you're into, well, I can't think of them now, but I mean, you see what got created from that team. Etsy, I think, or eBay isn't one, for instance, so it's like that can't work, like you'll recognize them all. So it's all like this global, those spook guys, it seems to be pretty normal. So, and OpenAI is another one of those. So that's going to be interesting. He's going to be able to, I don't understand how Elon Musk walks into the government and says, I'll build projects for this. But then he took over. How does he get this first? So I think if you go
Well, it's like a Or would that be like the oh, this is the way to stream. I'll put it right there.
Just gonna wait a couple more minutes until everyone comes up and then we'll start. So you guys keep chatting, we're not starting
Well, we're fucking good to go. You're live.
Ladies and gentlemen, we're about to get started. Everybody, attention real quick. I appreciate everyone for coming out. This is a special event. Obviously, these events are absolutely free. It's free education, so we appreciate the gratitude of you joining and supporting us. We're having a lesson today about basics of blockchain. And I'm going to introduce the gentleman over here to the left, Mr. Mark Shutt. That's our Director of Education. But just to give you a little background on Web3 Texas, some of you already have been to some previous events. Nick, our founder, Nick James couldn't be here, so I'm here in his presence. And the rest of the team are, we have our Director of NT over here, Jonathan, and of course Mark. And there's a few other ones around here somewhere.
Just like to talk about money.
Huh?
I just like to talk about the history of money.
Yeah, the history of money, that's the thing to talk to about that. But no, honestly, like, you know, there's a lot happening in the space and it moves really fast. And some of you guys are already familiar with the space and are advanced. Some of you have never heard of the word blockchain and are here to experience something new. But today's lesson will kind of fit both because there'll be some basic fundamental terminologies that we'll get into and some advanced stuff as well that Michelle, which is our guest speaker, is going to hold us down. But without further ado, Mark, go for it.
All right, guys, welcome in. This is our, yes, sir.
Do we still have somebody down to open the door? Because I have guests coming in.
I'm going down there after I wrap up my portion.
Oh,
Yeah, same with me. I'll be downstairs, so no worries.
Okay.
We'll get everyone up here. But welcome to the Basics of Blockchain. This is a continuation of our educational curriculum. We're going to be breaking down different aspects of the Web3 Texas educational framework. Last time we had our Intro to Web3 event. This time we'll be doing Basics of Blockchain, and each educational event will kind of continue in this series, doing dissecting different parts of Web3 and kind of giving introductions and then eventually getting into more advanced topics. So I will begin this presentation right now. We're going to have a word from our sponsor, Tim from Improving. So let's give him a round of applause, guys.
First off, I want to say thank you because this is part of what we do at Improving. We are really a community-focused consulting company, and I gotta ask, how many of you here have heard of Improving? All right, so we've got some folks who know about what we do. We are an IT services consulting company. We have a training practice which really focuses on agile practices for software development, as well as also software training. So if somebody doesn't understand a particular technology stack, we will work with that particular company to evolve their practice. And we are headquartered here in this very building. So corporate is co-located with the Dallas office, but we have offices throughout the United States, Mexico, and Canada. And we are now over 1,500 strong. We are backed by private equity, and we are like a rocket ship as far as where we're headed. So our goal is to become $1 billion company in the next 10 years, and we're already north of 250 million in annual revenue. So again, part of our community involvement and dedication, we believe firmly in the concept of conscious capitalism, and that's the reason why we like having groups like Web3. Our folks with Kubernetes and cloud downstairs come to our spaces because this is the way that we can give back. You know, we can foster greater, more integrated relationships throughout our community here in Dallas, and every one of our offices does this. So we just happen to be the flagship, and we continue to lead the way. So thank you. And I know this is your first time here. We look forward to having you guys come back because I'm kind of jealous. I know about Toyota Connected. Good friend of mine used to be the chief of Agile over there. So it's like, yeah, dude, I don't seriously. We're just as good as Toyota. So,
We're here. Thank you.
welcome.
All right, guys, so real quick, we always start with the Web3 Texas mission, which is to make Web3 accessible to all through simplified, captivating, and adaptive learning experiences on all mediums. So this is our one medium, our presentation, our live presentations. Real quick, just a note on donating. Donating is very appreciated. This is how we kind of run all of our events and how we function as a company, and kind of all of that is super appreciated. And so if you guys don't mind, at any point you want, there's a QR code to donate, and it's also on our website as well.
And this thing was a free event, so donations are always welcome.
And then if you guys wanted to host or sponsor a Web3 Texas event as well, that's always an option. Just please reach out to Nick or to Rob or anyone on the team, or the QR codes are also on our website, so more than happy to have someone help us out. And then at the end of this presentation, we'll be giving away a POAP, which we always do, which is a proof of attendance NFT, pretty much showing that you were here. It's like a digital ticket showing that you were really here and that you participated, and you'll have that for the rest of your life in your digital wallet. Now, without further ado, I'm going to introduce Vishal. Let's give him a round of applause. Woo!
So thank you, Mark, for the introduction. Thank you, everybody, for coming in here. My name is Vishal Bachani, and I've been working in the blockchain space, I would say, since the last 4 years. I started off my journey with working on private blockchains. And back in 2018, when blockchain, I would say, was in the initial stages, that's when I started working. So right now, I work as a product manager blockchain at Daffy, and I work as an advisor blockchain at Revision Lab, and that's the t-shirt I'm wearing. I have over 4 years of blockchain experience on the product side. So I'm not a developer, but I understand maybe a bit of blockchain concepts that I may be able to pass to you. My area of interest are, blockchain product manager, DeFi and payments, scalability of blockchain, and asset tokenization. So that's where I generally work. A bit about Revision Lab that we're focusing. I've got my CEO founder there, Rahul, sitting here, and he's the one who made me more passionate about blockchain. Revision Lab, we are a blockchain and Web3 consulting company. We focus on smart contract development, Web3 ecosystem development, asset tokenizations, DAOs, and DeFi. So that's something Revision Lab we focus on. So these are the class rules. Yeah, you can ask as many questions as you want. I may be able to learn a thing or something from you guys. You can do anything, and have your questions, and you can ask anytime. So, before starting to make this presentation, I was a little confused as to how I should proceed on giving this presentation, because blockchain in itself is a very huge and dynamic world. And wanted to make sure that everybody gets some gist out of it. So today we're going to talk about a bit of basics of blockchain. We'll touch base upon everything. I'll try to cover everything. We might not go technically advanced because we're not speaking from the developer perspective. It's just giving you all very basic knowledge about what blockchain is. So yeah, these are the terminologies that we're going to talk about today. Now, before I proceed, how many here know about blockchain or ever heard about blockchain? Oh, everybody heard. So I think I can change place now. What's your definition of blockchain? What do you feel is blockchain? What's your understanding of blockchain? Anybody wants? Sir, you were the first. What's your definition of blockchain?
My definition of blockchain, when I talk about blockchain, I talk a little bit more in terms of how it's amazing. And that is that this is in essence, carries information like a database does. But this database has never been defragged since 2009. It's never been hacked, unlike all the things we see in the news. It's never been hacked. It's never had to be backed up. This thing completely runs. There is a story about, I think it's actually an allegory, but a story about the government going to, I think it was Andreessen, saying, I think you need to shut down Bitcoin's blockchain. And he said, yeah, okay, no. Because you cannot stop it. The only thing that'll stop this will be the internet going down, and if that happens, we got way bigger problems. So, but basically blockchain is information, it's keys, and they are linked, they are chained one to the next. So each new block is created, so there's always a history of all the data, and there is a hash that cannot go back, but proves that it is the next block. And this is created through miners, probably now about top 5 companies, but those are miners.
Thank you, Mr. That was a great
Sure,
Yeah. we can switch places now. Yeah. So just would probably add or go a little back to what Sir just mentioned. we've been living in the world of centralization since a long time. We've been ruled. We've been when it comes to the power of internet, we've got very limited companies, very limited things which we are ruled when it comes to financial systems, when it comes to transactions, when it comes to talking about anything. And since we moved to a free world where we want a total decentralized system, where we want people to be free from being handed over one entity, or we want people to be more, work beyond the centralization, and that's where I think the word blockchain comes in. Now, let's divide the word block and chain into two parts. The reason I'm doing, dividing the word into block, into chain, into two parts is because it's a mixture of two words that would form the pure definition. Blockchain, just as I mentioned, is a distributed and a decentralized database. I don't call it database, I call it a record of information. Database is a misleading word. I would say it stores the record of information. So right now, if you're anywhere, if you're using your Web2, you are storing somewhere, maybe your AWS or somewhere storing your information. And at the end of the day, they are the owner of your data. They can wipe out. They're done. And they can remove your data, and anything can happen to that. But that's where the power of blockchain comes in. What blockchain provides is a way that there is no superior entity. It's a way where you store your data, where you store your transactions, distributed across the nodes, being totally decentralized. Now, how that works? Now, what is the connection between decentralization and blockchain? So let's suppose if I want to transfer money to anybody out there, let's suppose if I want to transfer some tokens out there. Now, I want this information not to be stored on some database which is controlled by everybody. I want to be stored in a proper decentralized manner. So that's where, the record of these transactions, there would be a record of transaction. That transaction record hash would be generated and then stored in a block. So you've got this block. Let's suppose this is a block, right? So you've got, okay, this information comes in this block, this block, this block. Once this block is completed, it becomes the part of the chain. So you see block containing all the information, all the hash becoming a part of the chain. And once your block is part of the blockchain, you cannot remove that. You cannot undo that. You cannot do anything. And these blocks, they get formed to each other. And all the nodes, all the entities of this blockchain would have the information. Hey, he carried out this transaction. Hey, there's a hash of this transaction. So there is total transparency. Nobody has a control over this node because every node has the same information. Everybody has the same information. And that's how you keep on adding block. And once you keep on adding block, it becomes a chain and a blockchain gets formed. Now, definitely, there has to be some starting point. There are Genesis blocks. That's the first time when you make this. I'll explain how nodes and everything work. But in order to explain the word blockchain, a block containing all the hash of the information and the information of the previous block is stored in a chain and called blockchain, unlike the normal databases or the normal information record that we see. So let's suppose if we look at this diagram, it says, hey, it's a P2P network, right? There is no decentralized authority. It's between nodes and nodes and nodes. So there's a computer who requested a transaction. Hey, I want to complete this transaction. In blockchain, we've got a method called validation. And in technical term, we called it consensus algorithm. But I'll let you know what consensus algorithm is. You validate that transaction, that transaction go through a certain hashing algorithms, certain staking, certain mining, a proper chain. Gets stored into the blockchain and joins the chain. So that's the continuous information, and that's how your blockchain gets added, and you see a network of blockchain. As so now I would be talking. So I spoke about this. Now my point is to spoke how the transactions are validated and how they become part of the block. Now, a lot of people here confused with the word transaction. And a lot of people think transaction means something related to payment. Whenever you hear the word transaction on blockchain, don't consider it payment. In blockchain, transaction means something is getting part of the block. Your information is transacting into the block. That's why what we call transactions. in our world, in Web2 world, we generally refer to transactions when we are paying something from card or banking transactions. But in terms of block, it's the transfer of your transactions to the block. That's why we call it transaction. So everything, anything that goes into the block is known as transaction. So whenever you hear that transaction is related to payments, just say no. It's blockchain, and your information is getting part of the blockchain. So this is how block looks like in a blockchain. You've got block 1, block 2, block 3. Now, if you see, this is a 0-0 block. It means it's a genesis block. I mean, it's a first block that's getting part of the network. Now you've got all the information stored. A hash of block would be generated and would be supplied to another, the second block. This block would contain the information about the last block and the information of itself, and same as it goes along. So even if you remove this block, let's suppose in parallel universe, you try to remove this, you would always have a previous hash of this block that would store this information. So there's no way you can undo it or you can remove it. You need to have another transaction if you want to make anything into the blockchain. So yeah, let's now deep dive into the blockchain lingo. Before I go into smart contracts, consensus algorithms, or nodes or anything, I want to discuss a little about there are basically two types of blockchains. One is a public blockchain and another is a private blockchain. The reason blockchain has to be public, it has to be always public, it has to be decentralized. But then there are some enterprises and there are certain data that needs to be secure. That's where private blockchain comes into the picture. It works. It is a distributed distributed database, but it's not permissionless. In the organization, every entities, every person is provided with some information access that particular blockchain. So public and private, they have different consensus algorithm. But as I move on, I think this would be more clear to you as to what I'm talking about right now. Now let's look at what a journey of transaction looks like, or what a smart contract is. Now, whenever I talk about smart contract to people, they think, hey, it's something very smart, or something, a contract that could execute by itself or something like that. But that's not the thing. Smart contract is basically a way which have certain logic written to it. It's a way that a person can communicate with the blockchain. It's a way through which you send any business logic to the blockchain. Let's suppose if you want to have anything on the blockchain, if you want to buy anything, if you want to have certain logics to be written on anything, that's where smart contracts come into the picture. Now, the reason why it is called smart contracts, why there is called transactions and contracts in blockchain, because it contains certain rules and logic. If you look in the real world, we have got contracts that has got certain rules and regulations. In the world of blockchain, you've got smart contracts that would have certain condition. Hey, if this payment proceed, transfer to this wallet, and this, it's a core business logic that's written into that smart contracts. And in order to execute that processing, we invoke that smart contract. So in a very basic term, I would say smart contract is a bridge that helps anybody to connect with the blockchain. It helps to have a logic that goes into the blockchain. So that's where smart contract comes into the picture. It's not smart, it's not a contract. It's a little bit of both, but it helps you to execute your logic. Let's suppose if I'm sending anything, Bitcoins to him, I have my private key, he has my private key. We both will sign that contract or smart contract, and that's where the transfer of asset take place. And over the years, blockchain has evolved, and we have had so many standards of smart contracts coming in as to how we interact with the blockchain. This is a very high level, I would say, to see what is in the blockchain network. I spoke about transaction in the blockchain, but there's a thing called nodes that you would hear a lot. Nodes. What are these nodes? Nodes are an entity in the blockchain that help to validate the transaction. Now, let's suppose there is a transaction happening between me and my colleague on blockchain. That transaction goes into the block. But before going into the block, there is a layer called validation layer, validator layer. So you might have heard the term called proof of work in Bitcoin. A lot of people hear about, energy consumption in Bitcoin and everything. That proof of work, or basically Ethereum was a proof of work. So once the transaction comes, you've got nodes around the world, you've got miners around the world who will look at this transaction. Hey, something is coming into the blockchain, but they wanted to make it secure. They wanted to mine the transaction. So there's an algorithm known as SHA-256. They'll work on the mathematical equation and generate a hash of this transaction. Whenever a hash generated, that would be transferred into the blockchain. So these are the validators layer who make sure that there are no fraudulent transaction and only secure transaction goes into the layer. And these are very important component of blockchain. You've got smart contracts connecting you with the blockchain. You've got validators who are helping in executing the transactions. Now, you see there is a block generators, validators, miners, transactions. So let's start, one by one. I've already spoken about smart contracts, but another thing that I really want to speak, is consensus algorithm. You might have all heard, even if you're a non-blockchain person, you might have heard that Ethereum is going towards a merge, it's going towards proof of stake. But what's proof of stake? I mean, people, there are a lot of assumptions that it might increase the TPS, it might decrease that, but that was not the case. Their case was different. So what is basically the consensus algorithm? For me, consensus algorithm is the backbone of any blockchain network, because consensus algorithm define as to how your transaction can be validated. Now, let's suppose if you consider Bitcoin. In Bitcoin, whatever transaction goes has to go through a proof of work mechanism. So you've got miners around the world who have got computational power who are looking at this transaction coming, solving the transaction, that mathematical part, which is basically a part of elliptic cryptography hash, but I won't go in detail. So people solving that equation, and once that equation is solved, it gets converted into SHA-256 algorithm and becomes a part of the network. Now, this is a way of validating the transaction. Ethereum works on proof of stake. You've got block producer who have got validators who sign those transactions. You validate certain nodes in the network to sign the transactions. Once they sign the transaction, that became a part of the network. So there are different consensus algorithms and as to how that becomes a part of it. So let's talk a bit about each consensus algorithm. There are a lot of consensus algorithms. There is proof of work, there's proof of stake, there's proof of capacity, proof of burn, proof of activity, proof of importance, and it just it just keeps on increasing. Every time you hear a new blockchain coming up, they're coming up with a new consensus algorithm. Now let's talk a bit about proof of work, as we've already discussed. So let's suppose you've got transaction coming in. That's where you've got your miner who mines that transaction, not the mining in real terms, but mining to solve that mathematical equation, solving the puzzle, and once it gets part of the block and it becomes a part of the network, it sends that new block to the network. This proof of work is a little energy consumption, and since you've got a lot of block and a lot of transaction coming, there is high throughput of the network. People are not able to solve the equations on time. And if let's suppose they are not able to solve they're not able to mine on time, new blocks are not created on time. If new blocks are not created, it means the transaction is not getting confirmed onto the network, which decreases the scalability of the blockchain, which is a major problem. So that's why they work a lot on how do we validate the transaction that it maintains its essence of blockchain, yet increases the throughput. Because let's suppose MasterCard or Visa does thousands of transactions a second. Right now, as I speak, there's no blockchain that can handle the number of transactions that Visa or MasterCard does. But as we evolve in the Web3 world, we need to go towards a point where we are able to handle those number of transactions. And that's where we want to see how we can make it more scalable. And I feel consensus algorithm is one of those part which can help you, increase the number of transactions. Now, proof of work, a lot of people know, but what happens in proof of stake is that there are nodes in the network. There are nodes in the network, but what you do is you delegate certain nodes. You stake your money with certain nodes, like certain nodes in the network. That hey, the community decides that hey, I feel these are the people who could validate our transactions, who could sign the transactions. So they don't mind the transaction; they sign the transaction. So after every certain time period, depending on what blockchain we are operating, EOS has another one, Binance might have some other rules. There are validators who are elected, and those validators, confirm your transactions. So in proof of work, you've got miners. There's no election, there's no staking, there's nothing. They solve the mathematical equation. They have energy consumption. Definitely, the level of hashing rate is very high there. It's very difficult to break the transaction of Bitcoin. But when it comes to proof of stake, it's little faster because you've got 21 block producer, you've got this number of cycle, you've got 6 seconds to produce a block. So you have to produce a block, and 21 block producer or 40 block producer, whatever the network is, has to validate the transaction. So this is also one of the ways through which transaction gets validated. Then this is how our delegate proof of stake mechanism works. So that's the way I said, you stake your coins. There are some delegated nodes, witnesses that validate your transactions, and then they get reward. Definitely in Bitcoin, the miners get the reward of Bitcoin, and in delegate proof of stake, you get some monthly rewards on transaction. So that's how, in general, delegate proof of stake or proof of stake consensus algorithm works. This is one of the EOS block producers, and I wanted to show that how the block producers look like. Yeah, please go ahead.
Some people feel that proof of stake will never have the security and reliability, resilience of proof of work. How do you feel?
I feel that yes, it is. It might not be the final step, but it is a stepping stone towards your scalability of the blockchain. Because we had proof of stake, now we are coming up with proof of stake authority. But what it does it right now here in proof of stake, anybody can be a node. So you don't even know all these people whether they are same entity or different entities, right? And if they're same entity and validating your transactions, then game is over. Then there is no decentralization. So I think it is a way that we start our point with. We've got a mechanism through which there's a community who elects nodes who can validate the transactions. But with proof of stake authority coming in, that their reputation is on stake. You've got big, I would say the authority of the nodes, and that's, I feel, is a step forward. I think consensus algorithm has to evolve, and that will keep on evolving. You've got proof of history coming up, proof of importance coming up. And I feel that blockchain would be, a combination of multiple different consensus algorithms, right? You have to take a security of proof of work, the scalability of proof of stake, or probably, throughput of some other consensus, and combine them to, evolve. So that's evolving space. That's what I feel. Proof of authority again is more on the private blockchain, because the validators here are organizations. Those work to create that permission blockchain. Now, one thing that is Byzantine fault tolerance. Byzantine fault tolerance is a very famous problem that happens, that as we speak about that, let's suppose, hey, you've got so many nodes in the network. What if some nodes went away? What if your proof of stake mechanism, you've got 20 validators, let's suppose 10 validators are gone. How do we work on solving that problem? So there's a thing called, practical Byzantine fault tolerance and PBFT. I don't want to go into a lot of detail. I would say it just works with your consensus algorithm to make sure that your network is secure. So what it does is it supplies the copy of each validation to each block. So even if any nodes get hampered or anything, everybody has a shared record of what happened in the past, and they come to an agreement that, hey, once they come to an agreement, that's where the transaction gets validated. So I say proof of consent is a derived version of Byzantine fault tolerance as to if there is, if there's any attack on the network. Let's suppose you've got 21 nodes in proof of stake. If there's an attack on the network, how do we handle that? So that's where, and I don't want to touch right now, so let's. Now, this is a little interesting thing. There's a thing that's going on right now is known as DAG. That's direct acyclic graphs. You've studied in computer science what a direct acyclic graphs is. But there's a blockchain IOTA that's working on increasing the blockchain scalability, and there's working on as to how we can make blockchain more scalable. So DAG is more like a revised version of blockchain. Now, if you see here, in blockchain, you're limited to a linear increase in blocks. So you've got one block that get added here, you've got one block that get added here, one block get added here. But what DAG does is, DAG is a direct acyclic graph. What they do is they say, hey, let's not order the transaction. You've got this Genesis block, you add another block, and this block is able to add block at any point of time. Now, there's a disadvantage of it because in blockchain, if this block is here, it means it was added first and then it was added last. But here it's not the case. Here your block, or what I call a piece of information, gets stored anywhere. So this is an evolving space. I just wanted to touch base so that you have an idea that there's a thing called DAG coming up in blockchain, where people would be able to transact more, where people would be able to see a scalable blockchain network. Now, as a product manager, somebody, if you are working on any blockchain network, right? How would you evaluate that which blockchain network is the best? What do you think? I wanted to ask that. What do you think would be the way to evaluate blockchain? What parameters should be used to evaluate any blockchain?
We're looking at the size of the community that participates in it, seeing if they have downtime, how long they've had that downtime, how big the developer team is. And I mean, most importantly, how many people are using it and how much it works.
Definitely. One of the points, because if the developer community is big, a lot of people are using and you get help when you're stuck there. That definitely is one of the points. But I think the first step is definitely working as what is the transaction per second. Now, blockchain evaluation criteria works in a different way. You first see that what is transaction per second. How many transaction is blockchain able to handle in a second? Let's suppose Ethereum, is able to handle X, Polygon might be able to handle 5X. So I would think going that route because my transaction would go to a block faster than it would go in any other blockchain. So the very first thing that when we look at to what blockchain we need to use for our use case is to look at the transaction per second as to how many transaction goes to in a block. Okay, this is one thing. The second thing is, what is the gas fees? I'm carrying out so many transactions. I suppose if I have to build 1,000 transactions, if I'm giving $10 for each transaction, I cannot afford that. So I look at what is the gas fees I'm paying, what is the mining fees, or what is the validation fees. Then I look at these are the two major criterion that I look at. Then definitely what he said, that community growth as to how big the community is. Then I look at the number of nodes. Then I look at the number of blocks that's being generated. Then I look at the number of dApps, decentralized apps that are being built. Then I look at the number of hash rate. Now, hash rate is the way to determine as to how strong your blockchain is. If you have high hash rate, it means it gets difficult. It is near impossible for anybody to break into blockchain. So these are the couple of things that we look into when it comes to looking at evaluating any blockchain platform. So I spoke about this, but just wanted to give a little insight about why is blockchain, people say it's immutable, people say you cannot undo the transaction. What is the science behind it? What is the logic behind it? So logic comes from a thing called SHA SHA-256 algorithm. This is a way of converting your file into a hash value. So once you get the hash, it would redirect to your file, but there's no way you can decrypt or convert back into the file. So SHA is a one-way algorithm, one-way encryption algorithm. If there's a file, there's a transaction happening, it converts into a secured form one way. That is one of the reasons why Bitcoin or such blockchain which employs this algorithm are so strong. Because let's suppose I say 2 plus 2 is 4. That's the answer I got from, but if I just give you 4, I tell you how did we come to know this? There are n number of ways of coming to 4 because that's what SHA-256 does. It decrypts your value, but there's no way you can go back to that value. That's why it's so strong and resilient. Talking about, now, when we look at blockchain, as we speak about how big the blockchain is, how distributed or decentralized the blockchain is, but I feel when we were in the Web 2 world, when internet came in, it was an evolving space. If you look at what people used to do in 1999 or 2000, is very different from how we use internet. Probably Azure, AWS didn't exist, but they came into the place so that they can make internet scalable. Without AWS, Azure, or Google Cloud, right now we cannot do anything if we don't have proper data pipelines, if we don't have proper database structures, proper languages. So blockchain is considered that also. You cannot rely totally everything on blockchain. You need to integrate an ecosystem on that. So there is one thing called interplanetary file storage, IPFS. So your blockchain has a certain disadvantage. It cannot store a huge quantity of file. That increases the right now, but because as we evolve in the blockchain space, we might have the capability. Now, how IPFS work is like, let's suppose I am I have a file, right? I don't want to go into the blockchain. What IPFS does is it takes your file, it will take your file, it will take that particular file, it will break that file into the pieces and store it across the world, store it across the peers. And how they do it, they have called a thing called content hash address. So let's suppose I have a PDF, I have a picture. That's mostly the picture I'm saying is because a lot of NFT marketplaces, they work on this. So how you combine that power? You take the file, you store it on IPFS, your file gets distributed. It's not stored in one particular place. Every node has an information. There's small pieces of sharded being, everywhere on the network of IPFS, and you store that hash of the file on the blockchain. So you've got file that is distributed across the network, already secure, and you've got a hash of the file on the blockchain. So you can use that hash of the file and power of IPFS to increase your scalability of blockchain. Now, how many have you used OpenSea or any NFT marketplace? Okay, everybody, that's great. So, how it works is, if they tend to store everything on blockchain, like pictures and everything, and when you go on, onto that NFT marketplace, it would be near impossible for them to fetch everything, to store everything. So what they do is they combine the power of IPFS. Whatever images, whatever data you see is on the IPFS, but the hash, but the smart contract, but the the power of NFTs on the blockchain. So it's decentralized. Even the file storage is decentralized, and the smart contract itself is on the blockchain. So mostly the way forward is definitely looking at IPFS. Right now, fetching a file from IPFS takes time. You might, but it's Filecoin is one of those storage which is continuously working, optimizing their performance. But as we grow along, this is one of the method that could help, blockchain. Now, I spoke, little bit about blockchain transactions, smart contracts, and everything. But what do you think is could be one of the best use cases of blockchain according to you, other than crypto and anything? What do you think? Other than NFT, I don't want NFT.
Supply chain,
How?
traceability.
You always
Really good
When I say
on
supply
blockchain,
chain,
they work well together.
when I say supply chain, I'm talking about just verification and traceability. Whether it's big manufacturing companies globally wide, that could be a hot mess. I think blockchain it's a good solution as we move forward.
Definitely. And any other use case other than NFT?
Yeah, I'm gonna piggyback on Rob. I'm gonna say luxury verification. That's actually a really big industry that's coming up.
Coming up.
You said that's not money, healthcare and taxes.
Healthcare,
Taxes, voting.
healthcare. You said you mean storing healthcare records?
Yeah, records.
Healthcare,
That's EHR.
records, whatnot, and then voting and taxes.
Oh, voting is definitely one of the things that's coming up blockchain. Any other? Yes, sir.
Yeah, title, land ownership.
One of the best examples.
Globally.
Yes, one of the
Worldwide.
best examples. Anything more?
Security, bonds.
DeFi, decent, derivatives of financial investors. Perfect. One of the best examples I can.
I'll be the oddball gaming.
Gaming, I knew. I knew. Gaming is coming. I knew that. Definitely, and so many other examples that we see across coming in. Today, I would two examples that I really like about blockchain, other than all other examples, is DeFi and tokenization of real estate asset, because I think that's where we are generating a lot of good value out of blockchain. Why would I say real estate tokenization? Because it just completely brought a new meaning to how your land, which you just bought 10 years ago, can get you something out of that. You could just put it in the digital form and earn money off it. And that's where I realized that blockchain has the real power to change things. I mean, who would have thought tokenization of a real estate? I mean, we all knew that we can buy a physical asset, but that's where I feel, blockchain takes a nice place. But let me explain how it basically works. So let's suppose if you have a piece of land, if you have a building, let's suppose this building or anything like that, and you want to bring it to blockchain. How do we bring building to the blockchain? There's a term called tokenization of real estate. You tokenize this asset into the blockchain. So what you do is, let's suppose through a smart contract, you tokenize this area and put this into, on blockchain, or read shares on the blockchain and earn money out of it. Now, let me show you one good example. So let's suppose, now that's a home that is owned by somebody. Let's suppose. So what you do is you create an LLC out of it. You make an LLC of that particular property. That, hey, I own this particular thing. What you do is you incorporate all your agreements on a digital space or on the law firm. Then what you do is there are certain token standards, and ERC20, ERC721, ERC115. There are certain token standards. So what are token standards in blockchain? Whenever we talk about token, it means transfer of any asset, and that transfer of asset, has to have certain standards. So real estate has certain standards. So you've got this area of land, okay? You had this area, all this documented, you formed an LLC. Now what you do is you break this into small pieces and create tokens out of it. So let's suppose if somebody owns this particular token out of it, or this owns three tokens of this. So let's suppose we had 100 tokens for this particular, or we divided, or we had 100 tokens for this area. Let's suppose somebody owns 3 tokens, 4 tokens. It means they own 3% of, or 4% of this asset in the digital mode. Now, what is this advantage is that, let's suppose if this area is rented, so the person who's paying this rent, that gets divided into that person who owned that token. So let's suppose I have this land and I feel I can do something out of it. I am getting rent out of it. Why not I tokenize and put them on blockchain so that I can get money, people who are buying my tokens, and I can distribute my rent. So it works two-way street, right? It's not just a land that's being there and you've got your record on a tokenized form. This is one of the examples, and it has a lot of evolving way because compliances and everything, and that's gonna come a long way as to how we see real estate. Metaverse coming in, which I am not a big fan of, but I feel is going to evolve, and a lot of things that needs to be changed.
Question?
Yes, sure.
So if a person buys a token for that real estate, what do they get in exchange?
So what we calculate is called a yield, what they get out of the token. Now what happens is there are multiple ways of getting that, return out of that. So let's suppose if you've got this land, then whatever rent you are getting for this land, if you've rented this land, and whatever rent you're getting, that gets divided into the percentage of ownership. So whatever rent you're getting on, let's suppose this is land, right? And you've rented this place, but you want this token to, because since you are the owner, right, you can do anything. So you made a digital ownership of it. People bought certain percentage of land because that's how REIT works, right? You get partial shares out of it, and that you make it on blockchain. So those people, they buy that percentage, and whatever rent or whatever the incoming cash flow is gets to them. So that's how they earn money.
So it sounds like an automatic lease agreement or automatic
I mean, so
revenue sharing.
It depends on what you're tokenizing, but
Right.
the tokenization also allows you to make it more easily tradable.
tradable, right? Trade
So you can
the
trade, but you can also, depending on what you're actually trading, you can earn the yield through like a REIT equivalent type model.
and that's where secondary marketplace comes into the picture, where you can trade your assets, right? So that's suppose if somebody believes, hey, this particular area has a good value that might increase, so you can trade that with somebody else. So it gets easy to trade any assets on the blockchain.
It is an added value. If you die, the smart contract can automatically send it to your heirs. But why would you not use an NFT? Just this truly a curious question. So you use the token, but why would you not?
NFT is a token. NFT is also a token.
Okay, so you merge those two words together then. That could be an NFT.
Yeah. I mean, it depends on what token standard you are using. But for real estate tokenization, we have this asset tokenization that we use. But definitely, real estate. Why cannot be real estate? Anything can be NFT these days. So yeah, we can have NFT as a standard for token to trade that particular thing. Let's suppose a picture of this building, right, can be traded as an NFT, right? So, but when it comes to real estate ownership, partial distribution of token, that's where we have a real estate standard. Now, NFT are also being partially traded these days, so you can have NFT as a real estate. So yeah, definitely.
So can I ask, would a good comparison be, I could tokenize the Empire State Building and aggregate the rent from floors 1 through 99 or whatever, right?
I mean, you can.
You could. That's
Yeah.
But a good comparison to that to the real world would be like I could tokenize the Apple company and sell its aggregate and yield and everything and dividends off of what it sells between iPhones and Apple Watches and AirPods.
You can tokenize anything, right? Yeah. It's the same way.
It's the same thing.
That's how the stock market works in the real life, right? You get dividends of the profit that you earn in a year. So that's how it works. That's where I'm coming right now.
Cool.
Another thing that I really like about finance, I'm more of a finance guy. So I've always believed, why do we need a mediator? I know we need mediator for fraud, compliance, AML, and everything. I feel with blockchain, with decentralized coming in picture, why cannot we use that to power DeFi? And that's something, that's a great work in progress. There are financial derivatives. You can lend on blockchain. You can borrow on blockchain. You can swap tokens on blockchain. You can trade on blockchain. Definitely with you might have heard of FTX crash, of being hacked. But I feel that happened in traditional finance also. 2008 crisis. Didn't that happen before that Great Depression? So I think these all are part and parcel of any world. And as you evolve, as you make sure, and even if you look at nowadays, all these strong blockchain or DeFi players are still there. Hov Labs, Compound, Uniswap, they're doing good because they have strong bases. So if you ever say that, hey, it was hacked and all, that's because we've got very active media and every people trying to put negative effect out of it. You should be careful what DeFi platform you're choosing, but on the other hand, it's the way out, and you need to choose that. Now, does anybody have ever invested in any DeFi or anything like that?
Anybody that does staking actually is drawing interest, right? So that's
DeFi. Yeah, one derivative, one use case of DeFi. You said, I think.
It's like basically staking, but you get their token as a reward for the staking. It's like token max or something.
That's also DeFi. That's definitely because you are staking, getting a yield out of it. That's also DeFi. It's not that you have to swap tokens or go into derivatives, yield bonds, just as we speak, right? One of the things that I like about DeFi being such a good thing is the liquidity providers. In DeFi, there's a thing called automated market makers. Automated market makers. Let's suppose I've got 10 A tokens, he's got 10 A tokens. Why cannot we create a pool of it so that people can swap it? Why cannot we create a world where I don't need any centralized authority and people can invest in my project, people can invest in me, and I provide them with a yield that is through smart contract, that is not through anything else. And that is where I feel, DeFi is a very big thing. It allows anybody to come in and to be a liquidity providers, to stake coins, to earn rewards. Now, if anybody have used Uniswap or Orb or Compound, it gets a little tricky to use. But there are two things that you should always keep in mind when investing in DeFi platform. It might little sound more if you're never invested in DeFi, but there's a thing called impermanent loss and slippages. These are the two things that you would hear a lot. That these are the okay. I'm just right. So I'll just quickly go through it. So when you're swapping any token, and let's suppose if you want to swap 10 tokens at $2, and since blockchain transaction happens very fast, by the time that transaction gets executed, the price increased from $10 to $12. The difference in the order that you made and order that you executed, that's in the normal traditional finance, that's impermanent loss, and that's very prevalent in DeFi. So whenever you are in the DeFi, make sure that impermanent loss is disabled and your order is not executed if they cross the limit. Slippages, another thing, if you keep your money in the pool, let's suppose if the price of the price of that particular token in the pool decreased, had you been traded earlier, so that's called slippages of the token. I just don't want to go in detail, but since it's 10 minutes, so let's wrap this up. Now, another exciting product that we are also right now working is which plan to replace Swift by to take more. I know it's a long way, but what we plan to do is we have the power of blockchain to create. And let's suppose if I'm in the United States, I want to transfer money to somebody in the United Kingdom. Transferring takes a lot of time. Transferring takes money. Transferring takes a lot of time. How could we power the blockchain? So what we do is we bring in stable coins. Somebody in the UK has stable coins. They put I want to send money to somebody. I want to send fiat to a person in UK. I'll ask him to put an order in the order book. I'll also place an order book. Place an order in the order of stable coins in the order book, which would lie on blockchain. We would match them, transfer their stable coins, and with the thing called open banking, that's very common these days, we would off-ramp their fiat. So that's how quickly that their fiat stable coin can get transferred and can be converted or liquidated their stable coins. Now, I just quickly talk about. Anybody has any idea what a sidechain or a level 2 blockchain is? Yes.
So like Ethereum has Polygon, so Polygon is kind of I'm pretty sure this is right. So Polygon is kind of this other side chain that you can use to before Ethereum was proof of stake. You would go to Polygon to do transactions like really fast, or to do like a bunch of transactions at once,
yes,
and things like that. So you don't have to spend, because when Ethereum was proof of work, one transaction might cost like $40. But if you bridged it over to the Polygon network, it would only, you could do that transaction 1,000 times for $4.
Yeah, so that's how. So what L2 or sidechain do, they also work on scalability. They take the essence of layer 1 blockchain like Ethereum or Binance has beacon chain or anybody or immutable X. So they take the power of real blockchain and create their own. And what they do is when they batch the transaction and then send it to the final blockchain. So you have the security of main blockchain, but you've got the increased throughput. So sidechains, level 2s, there's a little difference. Level 2s are more like, they sit on the top of layer 1 and they supply that final transaction to layer 1, which is the main blockchain in terms of Ethereum. Sidechain is something that works in parallel to a main chain. They have their compatibility of main chain, but then they finalize the transaction. So it's a way forward for making blockchain more scalable. Now, yeah, I spoke about advantages. You can transparent, traceability, reduce cost, automation, and spoke a lot about advantages of blockchain. Definitely disadvantage of blockchain, energy consumption. It could be expensive. Interportability, I won't say, because a lot of blockchains are interportable with bridge smart contracts. You can go from one blockchain to another. Difficult to stay. Again, working on that right now. Integration, because right now a lot of things are not blockchain supported. You cannot go on Amazon and buy through crypto, but there would be a time you would be able to buy a car with your crypto, or Tesla with your crypto, Dogecoins maybe. So so that's there are certain disadvantages of blockchain. Now, this is something, I've worked in blockchain space since 4 years, and a lot of people think that being in blockchain you have to be a developer. That's not the case. If you want to work in a blockchain space, you can work as a product manager blockchain, you can work as a blockchain analyst, you can work as a blockchain researcher, DeFi developer, smart contract developer, blockchain developer. So if you deep dive into the blockchain space, excuse me, there's so many opportunities out there that one can explore. You could be a non-tech guy and completely be in the blockchain space. So I think, yep, that's it from my side. Thank you.
Nice. We have about 6-7 more minutes. We're gonna go downstairs for the rest of the pizza. We want some cold pizza and leftover wine. But if you have any questions, that would be the time. You got a few minutes for some questions?
Yeah, I can do it.
I'll actually kick it off. Like, obviously with blockchain, and we cover the basics and we actually cover some advanced stuff, right? But like today in the real world, the more practical use, we have our phone, and I come from a background as a network engineer that in the 90s when the .com era was just starting, people were trying to figure out how to use the internet. And now today, nobody asks about TCP/IP using TCP protocol 80 and what is a hypertext transfer protocol. Like, these are questions that don't come up because we use it every day and we're so used to. So for you, because this is still early technology being adapted, how do you see the future of blockchain in terms of real life scenario cases where you can use your phone, you can use another sort of device? What do you see the future of blockchain?
No, I see, because it's not just my bread butter that I'm saying, but I see a great scope of blockchain, because as we, like, I'm not going very far. 4 years back, we didn't know we can do a real estate tokenization, or we can do work on DeFi platforms. You can have Unisoft, we can have so many trading platforms. Over the 4 years, blockchain has matured, but definitely I feel one of the things that blockchain still has to work on is scalability and the availability of transaction. Right now, if I do a transaction on Polygon, which was supposed to be very high throughput, can support high throughput of transactions, still takes a lot of time. And I feel the way blockchain is successful when we replace transaction system of Visa or MasterCard, that we handle that type of systems. So I think going forward, and I feel sometimes people say that blockchain is the solution to everything, but that's not the case. There are things where you cannot implement blockchain, and where it would take time for blockchain to come into being. So I feel there's a lot of future, lot of use case, but definitely it has to be scalable. It has to reduce the gas fees. It has to be more accessible and easy to use. So yeah, long way to go.
Any other questions?
Yeah, sure.
So given that there's about 24 core network routers, how does blockchain handle an international lockdown of those routers? Network routers.
You're talking about like points of access, like the big, like centralized around the world, what combines the internet.
Yeah, so Verizon, AT&T,
Oh, okay.
IMI, to name three. If there was a national emergency and those routers were to be locked down, effectively the chain could break because you couldn't prove proof of stake or proof of work. What is the resiliency strategy that is currently available compensate for a lack of network access?
So lack of network access has never been a problem in blockchain. Yet, definitely. So that's what I was, we were discussing that, as we evolve, if we have to make sure of scalability, we have to work on the failure also. We have to work on use cases. If we cannot work, there's a thing called practical poison and fault tolerance, which makes sure in case of network failure, everybody has an information, or everybody has a backup tool as to how to protect. But that's for a very limited number. And I feel as we grow on, how we validate the transaction, how we keep a copy of that ledger, and how we back those plans. So what I feel that right now we're working on layer 1, but there would be a layer 0 also. That would work as a backup layer. So if in case your L1 goes down, you might have an L0 that might come into the picture to take in that way. So that's my way of thinking that as blockchain involved, it can work that way.
Is there like a committee or body that tries to put so many nodes on each continent?
No. There's, every
Because-
blockchain network or every blockchain has some community that works on creating those nodes. But there's no.
For the purpose of resilience, because when you do a backup, you typically want to have an offsite backup because if your building burns down and your backup burns down with it, you should have an offsite more than a few miles or several miles away. So that's along the lines
So
of these questions.
what you're saying is
there
industry standards that you're talking about that in order
Does
to.
nobody care, or they're just putting wherever they can put up nodes and then?
It generally depends on the incentivization model for that particular blockchain, as well as the barrier to entry. So before, if you had to buy a Bitcoin miner to actually participate, that's gonna be pretty expensive. By default, you're gonna exclude a lot of people who can't necessarily afford all that. But different blockchains require different levels of technology in order to run the nodes, and a lot of that will contribute to how easy or hard it is to, be a participant on that blockchain.
So it's just organically growing as it may right now.
So let's suppose if I'll just speak on that point. Let's suppose if a Binance Smart Chain needs a validator, they need to at least take 10,000 worth of BNB and have to have certain hardware requirement. They cannot be if they disclose that they have certain hardware requirements. Once you see this hardware requirement, that's where I would vote for them. I cannot just vote for any nodes. I have to see the background and their failure of transactions, their fraudulency and everything. So that's where, every blockchain has set certain protocols as to how nodes would work.
So in a sense, this is always going to be hardware dependent.
Definitely. But again, work comes down to how the consensus works. Because proof of required a lot of hardware, proof of stake required less circuits.
And to back that up, it's going to be energy dependent as well.
So if you say energy dependent, Ethereum still manages the same resilience with 99% less energy consumption than it was.
But if the energy is not available,
Definitely.
you
Yeah.
can't operate a blockchain.
We got bigger problems, we don't have energy in this world.
If the networks are down and worried about energy, there's other things we need to worry about besides that.
But I think nuclear fusion just happened, so they might have an infinite energy. That just happened, so you never know, right?
Question of commercial
We got time for one more question before we head down? Does everybody know what the hell is blockchain?
Thank you guys.
All right, guys, let's give a round of applause for the call. Alrighty, so that will be the end of our presentation. Now you guys can go enjoy food, drinks downstairs.
Hold on a second. We still got a little prize since you made it to the end. Now you guys get to earn your own NFT.
Yes. So we'll be